All right, what I want to do now is to go over how to set up your graph for analysis and also how to copy it and paste it into a working document so you can submit your post lab. When you first get your graph in the lab, you're going to have something like this. Now, I've already changed the title here. The title should reflect what it is you're testing, should indicate what's happening with your independent variable. Remember, the independent variable always goes down on the x-axis. Should tell you what's happening or responding on the dependent variable, so it should be over here on the left. That's your dependent variable. Always put the dependent variable on your vertical axis and your independent variable on the horizontal axis. So the title should tell you how it is that what's happening on your with your independent variable is affecting your dependent variable. Okay, so I have here the effect of adding base to an acid solution on the pH. Now, you may have the effect of adding, and you'll indicate exactly the formula for the base, okay? And you may say to an unknown acid, okay? Because that's what you're testing, is an unknown acid. So, one of the things we want to do is to clean this up a little. That's an awfully fat curve right there, nice and smooth and everything. What we want to do is to make a little bit thinner line so it's easier to tell what's going on. So I'm going to go over here to Options and go to Graph Options. And rather than use point symbols, I'm going to use Connect Points, okay? And when I click Done, now I've got a thinner line and can tell a lot more about what's going on. I also want to analyze. So I'm going to go to Analyze and go to Examine. And you can see this vertical line. Now, this vertical line is helping me tell what's happening. See where the circle is here, where it's intersecting that red curve? That's telling me exactly what the values are for both the horizontal and vertical axis at that point. What we want to do is identify the best equivalency point on here. Well, there's kind of a long section here that could be the equivalency point. Now, you know, in general terms, you want the steepest place on the curve. But if we're really specific about the steepest place on the curve, we could do a little bit better than just visual examination. Or visibly examining, I might be right about there. That'll talk about the midpoint on the steepest part of that curve. Okay? Now, that's perfectly good, but it's not as specific as we could be. So to be more specific then, if we can do it, we'll try using what's called the first derivative. And that's a term from calculus, but in this case, the computer's going to do it for us. I'm going to go to Options, then Graph Options again. I'm going to Axes Options here and choose First Derivative. And it's going to give me a first derivative graph on here. Now, the key thing is the equivalency point occurs where the graph goes from bending in one direction to another direction. So if I'm over here to the left, the graph is bending, at least starting about here, it's sort of bending upwards, and then it starts to bend over. So the point at which it starts to bend over goes from that swinging upwards to swinging over is the steepest part of that curve. Now you can look right there and see that my circle on the green line, the green peak there, is not quite at the top. So what I'm going to do is shift from moving it around with my mouse to using the arrow buttons that are on the keyboard. I'm going to go to the right arrow, and I'm going to go to the right. There we go. There's the steepest part of the curve, and that much more specifically identifies where the inflection point on the graph is. The inflection point is where it goes from curving upwards to curving over, and then that is also the equivalency point. That's the point where you've added the base to the point where you've got the steepest part of the curve, and that's where the number of hydrogen ions from the dissociation associated with that cliff face equals the number of hydroxide ions in the solution. So that's called the equivalency point, and that's the point we want to record that volume of base being used. And so you can see on there that it's telling us what that is. It says in that box above the curve right here that the volume used at that point, that steep point, let me go back to it here. Whoop, I went by it. There we go. The volume used at that point is 50.46 milliliters, and it also identifies for us the pH point for that equivalency point. That's important. When you identify the equivalency point, you want to say that the equivalency occurred at a pH of 8.13. Now, your graph is going to be different because your acid's different. But one of the things I've got right now is this box is kind of on top of my line. I'm going to move it over here kind of out of the way a bit. I'm going to go back and I'm going to put my line, my circles there, that vertical line on that curve. Now, I want to save this graph, and I want to save it with that analysis vertical line there, okay, that examination line there. Well, first thing I got to do is highlight this graph. So I got to go back off of it again, just highlight somewhere in the white space here, so that you can see in the corners now on this graph I've got boxes. Okay? Well, these boxes in the corners then mean that I've highlighted the graph. So I'm going to go back and set up my vertical examination line again. There we go. And now I want to go and click Control C on the keyboard. Control C on the keyboard will copy that graph. And then I want to open up a Word document. I'll delete this one out and put it in here. Put in Control V. I'm going to enter the graph by entering Control V. And there's the graph on my Word document so that I can submit that for a grade. Now, it has that vertical examination line. It has the volume and the pH numbers we want on here. What it doesn't yet have is the figure label. Remember, figure labels have to be in a formal graph. So one of the things we want to do here is set this up, page layout, and go to setting this up at 0 so that my figure label is right up under the graph. Now I can type in a description. Figure description, well, figure label, first of all, has to have a figure number. That includes the word figure that's capitalized and the number of the graph, or figures are also illustrations. There are also pictures. But if this is the first one you have in your lab report, you're going to call it figure 1. And you have to follow that with a period. Then you're going to tell me 3 things in a figure label. Tell me what's in the graph, why it's important, and what analysis you can draw from that graph. Well, there are several analyses we can draw from the graph. In this particular graph, and your graph will be different, so you may have to say something different about yours, I can tell whether I have a weak acid or strong acid. I can tell whether I have a monoprotic acid or a diprotic or triprotic acid. I can tell by using these analysis tools, this vertical line, this examination line, that at the point where we're at the very peak of this first derivative, that identifies the best inflection point and therefore the best equivalency point. And that equivalency point is identified by pH, an APH of 8.13. And it also tells me that the volume of base I used at that equivalency point was 50.46 milliliters. All those are very important. All those can be analyzed from using this graph. All those need to be in your figure label.